Well, what is instantaneous velocity? Average velocity is generally over a period of time. If I consider instantaneous velocity, as the title suggests, it is the velocity at a given instant of time. For example, if you look at the speedometer of your vehicle, it shows what is called as instantaneous velocity or speed, more of speed. That means at that instant. Now, we have already seen that if I want to consider the motion like this is the origin, and as the velocity keeps changing, in this case, if I consider different instants of time, velocity keeps changing. So, what do I do? I will consider a very short interval of time. For example, this is a very short interval of time. It is very small, over which the displacement of the particle is delta x. So, let me repeat, over this short interval of time delta t, the displacement is delta x. So, now you know that the velocity is given by delta x by delta t, but if I want the instantaneous velocity, I will make this delta t very small, which is generally written like this: limit of delta t tending to 0. This is the mathematical language of telling the fact that I have chosen a very small interval of time. It is so small that over that small interval of time, the velocity can be assumed to be constant. So, we can say that over these extremely short intervals of time, there is a stepwise variation of velocity, not a continuous variation of velocity. Thus, we can write the instantaneous velocity as limit of delta x by delta t as delta t tends to 0, which is mathematically written in the language of calculus as dx by dt. If I consider a body moving along a straight line path along a definite direction, for example, this is the initial position and this is the final position, this is xi and this is xf, do you notice that the distance travelled and displacement are equal to each other? Do you notice that? If distance travelled is equal to displacement of the particle, then the instantaneous speed and the instantaneous velocity are also equal to each other. Thus, one method of calculating the instantaneous velocity is to write it like this. The other method is to make use of the graph. How to find the instantaneous velocity from displacement time graph is our question. Now, this is our graph. As you can notice, the velocity keeps varying. So, this is the velocity, this is the speed position versus time graph. And now, I want the instantaneous velocity at position A. So, now what should I do? I should draw tangent at that point, and the tangent cuts the x-axis here, and the angle subtended here is theta, and then the slope of the tangent at that point gives us the instantaneous velocity. But how to calculate the slope? Slope is given by tan theta, or graphically the instantaneous velocity is equal to tan theta, theta being the angle subtended by the tangent with the axis, with the time axis.